For centuries, humanity gazed at the stars with a longing to explore the cosmos. The night sky, with its twinkling stars and mysterious planets, has always ignited our imagination and curiosity. We dreamed of what lay beyond our world, of the secrets the universe held, and of the possibility of reaching out and touching the stars. The challenge was clear. Breaking free from Earth's gravity demanded immense power, a feat that required not just advanced technology but also a deep understanding of physics and engineering. The sheer force needed to escape our planet's gravitational pull was staggering, and that power came at a steep price. The cost of building and launching these powerful machines was astronomical, both in terms of resources and finances. Traditional rockets, those behemoths of fire and fury, were built for a single, glorious purpose: to propel astronauts and payloads into the inky blackness of space. These marvels of engineering were designed for one-time use, their intricate systems and components meticulously crafted for a single mission. Then, their job complete, they would plummet back to Earth, destined to crash into the ocean, their potential for future voyages extinguished. This single-use model was not only wasteful but also incredibly expensive, as each mission required a brand new rocket. Space exploration was a costly endeavor, a realm reserved for governments and their colossal budgets. The high costs limited the frequency and scope of missions, making space a domain accessible only to a select few. The sheer expense of building a new rocket for every launch limited our access to the final frontier. Each mission required years of planning, vast amounts of resources, and significant financial investment. But what if there was a better way? What if we could rethink the entire approach to space travel? What if we could innovate and find a solution that would make space exploration more sustainable and cost-effective? What if we could engineer rockets that could not only reach space but also return to Earth intact, ready to be prepped for another audacious journey? This idea, once considered a distant dream, began to take shape as a tangible goal. Enter SpaceX, a company with a bold vision and the audacity to challenge the status quo. Founded in 2002, SpaceX aimed to revolutionize the space industry by making space travel more accessible and affordable. Founded by Elon Musk, a visionary entrepreneur with a passion for pushing the boundaries of technology, SpaceX set out to revolutionize space travel. Musk's vision was not just about reaching space but about making it a place where humanity could thrive. Their goal was simple yet ambitious: to make spaceflight more affordable, more sustainable, and ultimately, as routine as commercial air travel. This vision required a complete overhaul of traditional rocket design and operations. The key to unlocking this future lay in a concept that had long tantalized engineers and scientists: rocket reusability. By designing rockets that could be reused multiple times, SpaceX aimed to drastically reduce the cost of space travel. If rockets could be designed to safely return to Earth and be launched again, the cost of space exploration would plummet, making it feasible for more frequent missions and broader participation, opening up a universe of possibilities for scientific discovery, commercial ventures, and the expansion of humanity beyond our home planet. The dream of making space accessible to all was no longer a distant fantasy, but a rapidly approaching reality, thanks to the revolutionary advancements in rocketry spearheaded by SpaceX. Before SpaceX, space travel was synonymous with exorbitant costs. The dream of reaching the stars came with a price tag that was almost unimaginable. Every launch was a multi-billion-dollar gamble, with rockets discarded into the ocean after a single use. These massive structures, built with cutting-edge technology and immense resources, were used once and then abandoned. This financial burden severely limited the frequency of missions and the scope of our ambitions in space. The high costs meant that only a few missions could be planned each year, and each mission had to be meticulously justified. Traditional rockets, marvels of engineering though they were essentially elaborate fireworks displays. They were designed to dazzle and inspire, but their utility was fleeting. Their intricate systems of engines, fuel tanks, and avionics were designed for a single explosive burst of energy, culminating in the delivery of their precious cargo to orbit. Each component was crafted with precision, yet destined for a brief moment of glory. Once this mission was accomplished, their fate was sealed. The stages would detach and fall back to Earth, often landing in remote ocean areas, far from any chance of recovery. These spent rockets, carrying a hefty price tag, would plunge back to Earth, their fiery demise a testament to the extraordinary forces they had overcome. The spectacle of re-entry was both awe-inspiring and tragic, as millions of dollars worth of technology were incinerated. The cost of this disposability was staggering, effectively pricing out all but the wealthiest nations and organizations from the space race. Smaller countries and private entities could only dream of participating in this grand adventure. SpaceX recognized this inherent inefficiency as a fundamental barrier to realizing humanity's full potential in space. They saw that the future of space exploration required a new approach, one that was sustainable and cost-effective. They understood that to truly open up the cosmos, a paradigm shift was needed. A move away from the disposable rocket model towards a future where spacecraft could be flown and reflown, just like their terrestrial counterparts. This vision of reusable rockets promised to revolutionize space travel, making it more accessible and affordable for all. SpaceX's engineers, a team of brilliant minds driven by a shared passion for space exploration, embarked on a mission to defy conventional wisdom. They challenged the assumption that rockets were inherently disposable, meticulously studying the physics of atmospheric re-entry and the intricacies of controlled descent. Their approach was grounded in innovation and a relentless pursuit of efficiency. They sought to develop technologies that would enable rockets to not only survive the scorching heat and immense pressure of re-entry, but also to land with the precision of a feather, ready to be flown again. At the heart of their strategy was the development of the Falcon 9, a two-stage rocket designed from the ground up with reusability in mind. Unlike its predecessors, the Falcon 9 was equipped with a suite of advanced technologies, including hypersonic grid fins, powerful Merlin engines capable of deep throttling, and sophisticated guidance systems. These innovations would prove crucial in transforming the Falcon 9 from a conventional rocket into a reusable space vehicle, paving the way for a new era of sustainable and affordable space travel. Section 4. Touchdown. The Falcon 9's historic landing. On December 21, 2015, SpaceX achieved a milestone that would forever alter the course of spaceflight. After delivering a payload of satellites into orbit, the first stage of a Falcon 9 rocket descended back to Earth, guided by its onboard computer and a symphony of precisely controlled burns. The world watched with bated breath as the rocket, a slender pillar of fire and metal, approached its landing site. The roar of its engines echoed across the Florida coastline, a testament to the immense power being harnessed and tamed. Then, in a moment that defied decades of conventional wisdom, the Falcon 9 touched down gently on its designated landing pad. The cheers of SpaceX engineers erupted, a mixture of relief, elation, and the realization that they had just rewritten the rules of space travel. This historic landing marked the dawn of a new era in space exploration, one where rockets were no longer destined for a watery grave but could instead return to Earth, ready to be prepped for another mission. Section 5. Slashing the cost of space travel. SpaceX's commitment to reusability has had a profound impact on the economics of space travel. By focusing on innovative engineering and cutting-edge technology, they have revolutionized the way we think about launching rockets. By recovering and reusing rocket components, they have significantly reduced the cost of launching payloads into orbit, making space more accessible than ever before. This approach not only saves money but also reduces waste, contributing to a more sustainable future for space exploration. The traditional model of expendable rockets meant that each launch carried the full burden of building an entirely new vehicle, a cost that inevitably drove up the price tag for space missions. This method was not only expensive but also inefficient, as it required the construction of new rockets for every single mission. With the Falcon 9, SpaceX introduced a paradigm shift, demonstrating that rockets could be treated more like airplanes, capable of multiple flights with refurbishment between missions. This concept of reusability has been a game-changer, proving that rockets can be launched, landed, and relaunched with minimal additional costs. This reusability factor has translated into substantial cost savings, with SpaceX estimating that reusing a Falcon 9 first stage can reduce launch costs by as much as 30%. These savings are not just theoretical, they have been realized in numerous successful missions, showcasing the practical benefits of this innovative approach. This reduction in price has opened up opportunities for a wider range of customers, from government agencies to private companies and even research institutions, to access space. The lower costs have enabled more frequent launches, allowing for a greater number of scientific experiments, commercial ventures, and exploratory missions. No longer is space exploration the exclusive domain of nations with vast budgets. The democratization of space access means that smaller countries, startups, and educational institutions can now participate in space missions, fostering innovation and collaboration on a global scale. SpaceX's innovative approach has democratized access to the cosmos, fostering a new era of competition and collaboration in the pursuit of space exploration. This new landscape encourages diverse players to contribute to the advancement of space technology, leading to rapid progress and exciting new discoveries.